Assalamu alaikum. The topic is high derivative, and you know that we use high derivative to check the stationary point is maximum or minimum. ठीक है. अब यहाँ पे the question is determine the value of x where x is greater than and equals to 0 and less than and equals to pi, for which the curve y is equals to 2 cos x plus 3 sin x as a stationary point. So we have to find out the value of x at the stationary point, and we have to determine the nature of the point, means that we have to check the stationary point is maximum or minimum. So first of all, we have to find out the stationary point, and you know at the stationary point the gradient is always 0. You know if the curve is like this, the stationary point will be at the maximum point, and you know if the tangent is horizontal or parallel to the x-axis, so the gradient at this point is equals to 0. ठीक है. So first of all we will differentiate the given equation, that is y is equals to 2 cos x plus 3 sin x. I am going to differentiate this dy upon dx. You know the differential of cos x is minus sin x, so it will become minus 2 sin x, and the differential of sin x is cos x, so it will be 3 cos x. ठीक है. So we have differentiated the given equation. Now we need the stationary point, and we have discussed right now that the stationary at the stationary point dy upon dx is equals to 0. ठीक है. So for stationary point, dy upon dx must be equals to 0. So I am taking this minus 2 sin x plus 3 cos x equals to 0, or you can say I am substituting 0 in place of dy upon dx. Now if I shift 3 cos x to the other side, it will become minus 3 cos x. Minus and minus can be cancelled, and if I bring this cos x to this left hand side, so it can be written like this: sin x over cos x and is equals to 3 over 2. We know that sin upon cos is tan, so it will become tan x is equals to 3 upon 2. ठीक है. We need to find out the value of x, since the domain is from 0 till pi. 0 till pi means k from 0 till 180, and tan is positive in the first and third quadrant, but we can go till the second quadrant. ठीक है. We cannot go beyond to it because the domain is from 0 till pi. So it means that we will get only one value of x, that will be in the first quadrant. So x is equals to tan inverse of 3 over 2. Check it out. Shift tan 3 over 2, it's coming 0.9827. So to 3 significant figures we can take 0.983. 0.983. So the value of x is coming 0.983. This is the value of x of the stationary point. So this is the stationary point where dy over dx is 0. Okay. Now I have to check this stationary point is maximum or minimum, because in the second part of the question it is written determine the nature of this point. To determine the nature of this point क्या करना पड़ेगा मुझे? I have to find out the second derivative of the differentiated value. The differentiated value is dy upon dx is equals to minus 2 sin x minus 2 sin x plus 3 cos x. I have to differentiate it again. When I will differentiate it again, I will write d square y over dx square. This is the symbolic representation of the second derivative, or you can say the higher derivative. When I differentiate this sin x, you know it will become cos x, and the differential of cos x is minus sin x, so this will become minus 3 sin x. Now I need to substitute the value of x in this second derivative. Substituting x is equals to 0.983 in place of x. तो minus 2 cos 0.983 and minus 3 sin 0.983. ठीक है? Certainly we will get the negative value because both the terms are negative. Minus 2 cos 0.983 and minus 3 sin 0.983. You can see we are getting minus 3.61 minus 3.61. Since d square y over dx square is coming negative, that is it is coming less than 0. So therefore the value of x of the stationary point, that is x is equals to 0.983, is maximum. So this is the nature of the point. If d square y over dx square comes less than 0, so it means that the value of x of the stationary point is representing the maximum point. Or if it comes greater than 0, यानी d square y over dx square, if it comes positive, तो this value will become minimum. ठीक है, ये minimum point हो जाता. So this is all about the higher derivative and the stationary point. Okay.